Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers Edexcel Paper 2. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Right, 4.5 times 10 to the 5 is an ordinary number. Okay, so if I got 4.5 and I'm going to times it through by 10 to the power 5, that's equivalent of moving the decimal point 5 jumps to the right, isn't it? So it's going to go 1, 2, 3, 4, 5 jumps. So our decimal point is going to end up over here, which means I'd need to kind of fill in some extra zeros along the way in order to that I can drop the decimal point there. So that gives me 450,000. The other way of thinking about it is 10 to the 5 is hundreds of thousands, so it kind of just translates your number into hundreds of thousands. Right, 0.007 in standard form. The way I do this, I just do it 7 times 10 and then I count the number of zeros I can see. So I can see 1, 2, 3 there, so it's going to be 10 to the minus 3. Okay, so 7 times 10 to the minus 3. Work out 4.2 times 10 to the 3 plus 5.3 times 10 to the 2. Give your answer in standard form. That's really easy with a calculator. Just have to type it in. So 4.2. You've got this exponent key down here with times 10 to the x written on it. So just press that, and then the only other thing you need to put in it is the power, which is 3. Okay, so 4.2 times 10 to the 3 plus 5.3. Type in the manticipart. Press that button down there, times 10 to the x, and then tap in the power, which is 2. Okay, so what does that equal to? That equals to 4730, but remember they want it in standard form, don't they? Okay, so I'm going to have to rewrite that as the manticipart as a number between 1 and 10. It's going to become 4.73. What's the power of 10? Well, the decimal point would start here. It's going to end up going 3 jumps to the left. So that is going to be times 10 to the 3 then, isn't it? So 4.73 times 10 to the 3. Beth drives 200 miles in 4 hours. She drives the first 18 miles at an average speed of 36 miles per hour. Work out the average speed of the rest of the journey. So we've got a question here involving distance, speed and time. You can remember how these are related using this triangle. It's the DST triangle. D at the top, S and then T. They're alphabetically listed, aren't they? D, then S and T. And this tells you how those 3 things are related to each other. Okay, now we're going to look at this journey in 3 different ways. First off, we're going to look at the whole journey, so the total journey. Now the total journey, what is D, what is S, what is T? Well, we've got the distance, which is 200 miles. We don't have the speed, but we have the time, which is 4 hours. But we can find S then using the other two. So we just cross off, kind of stick your finger on top of the one you're trying to find, in this case S, and then the triangle tells you what to do with the other two. So average speed, oops, let's write in blue. Average speed is distance traveled divided by time taken. In this case, it's going to be 200 divided by 4, which is 50, isn't it? 50 miles per hour. Okay, so that's the average speed for the whole journey. Right, so does that help us? What does the next part says? It says she drives the first 18 miles at an average speed of 36. So I'm going to write this. This is the stage 1 then of the journey. There's 2-stage journey, isn't there? The first section, we know D and we know S, but we don't know T. So let's find T. Let's see if that helps. So we know that the distance is 18. We know that the speed is 36. So what we want to find is time. So again, going back to the DST triangle, if you cover up T, you can see that time is going to be distance divided by speed. Okay, which is going to be 18 divided by 36, which looks like a half to me, 0.5. So what's the units of that then? So this is time in hours then, isn't it? So 0.5 hours, that's half an hour or 30 minutes. Okay, I'm just going to leave it in hours for now. Okay, so then stage 2 of the journey, what do we know about this stage? Do we know anything about it? We know the total distance traveled was 200, and we know that distance traveled in stage 1 was 18. So the distance traveled in stage 2 then is going to be 200 minus 18, and isn't that's going to be 182 miles. Do we know the speed? No, that's what we're trying to find. Do we know the time? Well, again, we know that the time for the whole journey was 4 hours. We've just calculated the time for stage 1 to be half an hour. So that leaves us with 4 subtract half an hour. That leaves us with 3.5 hours then, doesn't it? For the second stage of the journey. Okay, and then we want to find the average speed of this part of the journey. So again, from the triangle, cover up S, it tells me that speed equals distance over time, which is now 182 divided by 3.5. Okay, time to reach for a calculator, I think. So 182 divided by 3.5 comes out to be 52. Okay, so that's 52 miles per hour then. Use Pythagoras theorem to work out the value of x. Okay, so x is the long side, it's the hypotenuse, isn't it, of the right angle triangle. You can tell because it's opposite the right angle. So this is the hypotenuse. So we call the hypotenuse C, and we can just label the other ones A and B. And then Pythagoras theorem states that c squared, the square on the hypotenuse, equals a squared plus b squared, the sum of the squares on the other two sides. So it's going to be 32 squared plus 60 squared. So then c is, what's c then? Okay, I'm just going to type that into my calculator. So 32 squared plus 60 squared comes to 4,624. 4,624, and then so c is going to be the square root of that then, isn't it? So root answer comes to 68. Okay, just a good idea to just think about 68 here. Whenever you do one of these things, does 68 look right? Yeah, it's slightly longer than 60 and 32, isn't it? Looks okay in that triangle. 68. Doug owes an amount of £600. He wants to pay off this amount in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. I don't think this is going to work, Doug. If you're just paying back 20% of what you still owe, this is a kind of never-ending sum, isn't it? Basically, it's like compound interest, isn't it? So you've got for percentages, final, original, multiplier.
The final is what we're trying to find here. The original is 600, and the multiplier, so if he's paying back 20%, then he's retaining 80% of the value then, isn't he? So you're basically timesing through by 0.8 each time. So after 5 months of paying back 20%, your final then equals original times multiplier, which is 600 times 0.8, but we're doing this 5 times, aren't we? So it's to the power of 5. So after 5 months, how much will be left? 600 times 0.8 to the power of 5. That gives me £196.61. That's remaining to be paid, isn't it? So he has not cleared the £600. Okay, I think I'm just going to sign off like that. So I've shown it, haven't I?
Question 9. The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. Work out the interquartile range of the information in the box plot. Okay, so in this box plot, this down here is Q1, the lower quartile, and this up here is Q3, that's the upper quartile. Okay, so to work out the interquartile range, what you're going to be doing is you're going to be subtracting Q1 from Q3. So it's Q3 minus Q1 basically. Okay, so that's what you need. In other words, it's the width of the box. Okay, that is what you're calculating. Okay, so the interquartile range is the same thing as the width of that box there. Okay, so can you see Q3 there? Just reading down, look, it's there. So this scale is going from 160 to 200 in 10 jumps. So it's spanning 40 units in 10 jumps. That means each little jump must be +4 then, isn't it? So it is 160, 164, 168, 172, 176, 180, 184, 188. Okay, so the Q3 score is 188. In the other direction, Q1, again, counting up. Where's Q1? Q1 is, it's actually halfway between those blocks, isn't it? I see that as. So that is 40, 44, 48, and halfway between 48 and 52. So I'm going to say that's 50. Okay, so that's 50. Okay, so the interquartile range is going to be 188, take away 50, so that is 138. Okay. Becky says 50% of the people waited for at least 2 hours. Is Becky correct? Explain why. 50% of the people waited for at least 2 hours. Okay, so 50% is where the median lies. Okay, remember the lower quartile lies 25 of the way through your data. The upper quartile is 75% of the way through your data. The median lies 50% through your data. Okay, so that little stripe in the middle of the box is at the median value, and so the median value here is 120. In other words, it is 2 hours. So I'm going to say the median is 2 hours. Okay, so what does it mean if the median is 2 hours? It means that that middle person waited 2 hours. Now everybody to the right of the median waited more than 2 hours. Everyone to the left of the median waited 2 hours or less. Okay, so I think she's right, because if the median person is at 50%, that means 50% of the people are to the right of that,
and that means 50% must have waited for at least 2 hours. So the median is at 2 hours, so she's correct. So she is correct, as 50% of people waited the median time or longer. Okay, so 50% of the people waited the median time or longer. Okay, so I think that's my answer. Yep, she's right. For part C, we've got an additional data table here. So the table gives information about the length of time in minutes some people waited to see the doctor at the same hospital on Tuesday. Okay, so we've got the shortest time, the lowest quartile, the median, the upper quartile, and the longest time. Becky was asked to compare the distribution of the lengths of times people waited on Monday with the distribution of the lengths of times people waited on Tuesday. She wrote that people had to wait longer on Tuesday than on Monday. Give one reason why Becky may be wrong. Well, I think the first thing I'm going to say is the median, isn't it? The median is 100 here. So on average, the people on Tuesday then waited 100 minutes, whereas on Monday, on average, the people waited 120 minutes. So it seems to me that on average, people actually waited less time on Tuesday than on Monday. So I'm going to say the median for Tuesday is 100 minutes compared to a median of 120 minutes on Monday, which may indicate that people on average waited longer on Monday. Okay, so give one reason why she might be wrong. The median for Tuesday is 100 minutes compared to a median of 120 minutes on Monday, which may indicate that people on average waited longer on Monday. And that is kind of contradicting her hypothesis there that people waited longer on Tuesday, isn't it? Okay. Question 10. The parallelogram and the trapezium have the same area. The ratio x to y is 3 to 5. Find the value of x and the value of y. You must show your working. Okay. So we've got a parallelogram. We've got all the dimensions for it. We've got a trapezium where we've only got one of the dimensions for it. But I guess we can work out what those dimensions are by using the fact that they have the same area. So I'm going to find the area of the parallelogram first, and then I can equate the trapezium with it, and then hopefully I can then work out what x and y are. Okay, so let's start with the parallelogram. So the area of a parallelogram, you should know, is base times height. Now the base of this parallelogram is 8. The height is 5. So that's the base there, look from there to there. And the height is here, that's 5. So what is the 6 doing there? It's there just to confuddle you basically, isn't it? So we don't need that one. Okay, so it's just 8 times 5. It has an area of 40. Okay, so once we know that the area of the parallelogram is 40, then we know that the area of the trapezium is also 40. Now the area of a trapezium is a half times your a plus b value times your h value. Okay, so that is a half times, well, a and b are your two parallel sides. In this case, a is x and b is y. Okay, and then h is the distance between them, so h is going to be that distance there, look. Okay, so subbing those carefully in. So I'm going to get x plus y times 4. Okay, so what does that tell me? Well, I can cancel that half into the 4, giving me 2. So that's going to be 2 lots of x plus y. Now, I already worked out what the area was. It's equal to 40 because these two things have the same area. So if 2 lots of x plus y is 40, then x plus y must be 20. Okay, just dividing both sides by 2. So my values for x and y, they add up to 20, and they're in the ratio of 3 to 5. So I know that they're in the ratio of 3 to 5 and that they add up to 20. So how does that help me? I guess I could say that 3 plus 5 adds up to, so if you think about the ratio of 3 to 5, that kind of adds up to 8, doesn't it? So 3 plus 5 is equal to 8. Now I want the ratio parts to add up to 20. So what would I have to do then to make the ratio parts add up to 20? I think what I need to do is times it by like 2.5, because 8 goes into 22 and a half times. Double 8 gets 16, and half of 8 is 4, 16 and 4 make 20. Okay, so if I times it by 2.5, I'd get 20. So if I take this ratio of 3 to 5 and I times it by 2.5, then 3 lots of 2.5 is going to be, what's that, 7.5? 7.5, and 5 lots of 2.5, that's going to be 12.5. 12.5, okay? So that means I can say that x must be 7.5 centimeters and y must be 12.5 centimeters. Okay. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Okay. So we know that Joe to Kyle is in the ratio of 7 to n. Now, Joe gets 35% of the money. So what percentage would be left then for Kyle? Kyle's going to get the rest then, isn't he? So if I've got 100% and I let Joe have 35% of it, then Kyle is going to get 65% of it. Okay? Can you see that that is, well, the relationship between these two numbers, that's 5 times bigger, isn't it? Okay? So then n, if I multiply n by 5, I'm going to get 65. In other words, n then must be 65 divided by 5. 65 divided by 5 is 13, so n is 13. Use trigonometry to work out the size of angle x. Okay? Right, so trigonometry is a right angle triangle, so it's about Soccer, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there, cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which I'm just going to round off to 1 decimal place, 25.8. Ax to the power 6, all raised to the power of 1 over n, is equal to 7x to the 3. Work out the value of a and the value of n. Okay. So I think what I'm going to do is I'm just going to take this more complicated side, and I'm going to see if I can make it look more like the side on the 7x cubed. Okay, and then I can compare it a little bit better. So it's equal to ax to the 6 all raised to the power of 1 over n, isn't it? Okay, Now, when you've got an index of an index like this, you have to apply the index to both things inside the bracket like that, so it distributes over multiplication. So what I'm going to get is I'm going to get a to the power of 1 over n, x to the power of 6 over n, okay? And that is equal to the right hand side, which is 7x cubed, okay? Now, if these two things are equal, then both parts of them need to be equal. That means that this part needs to be equal to that, and it means that this part over here must be equal to that. Okay, so I'm going to use that to form two equations. I'm going to say a to the power of 1 over n must be equal to 7, and I'm going to say that 6 over n must be equal to 3. Okay, now that second one looks easier to solve to me. Multiplying both sides through by n, I'm going to get 6 is equal to 3n, and then dividing both sides by 3, I'm going to get n is equal to 2. Okay, so once I know that, I can then sub it into the other half, and I can say, well, a to the power of a half is equal to 7. So then to get a, then I'm going to have to kind of square both sides, aren't I? So if I square that and square that, I'm going to get a is equal to 7 squared is equal to 49. Okay, so that means a is 49 and n is 2. Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. Fran and Gary share their sweets in a ratio of 2 to 3. Olivia and Jessica share their sweets in a ratio of 9 to 1. Fran got W sweets, Gary got X sweets, Olivia got Y sweets, Jessica got Z sweets. Find the simplest form of W to X to Y to Z. Oh my days, what's going on here? Right, okay, this is a bit complicated, isn't it? I think we're going to have to go through this a bit more slowly. Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. So Olivia and Jessica have half as many as Fran and Gary. So what do we know? We know that Fran got W sweets and Gary got X sweets. So if I add W and X together, that is Fran and Gary's total, isn't it? Fran and Gary, that's those two. Olivia and Jessica had Y and Z. So if I add those together, I'm going to get Y plus Z. So those two together is that and that. I've got a feeling I'm just going to look at W to X to Y to Z and start putting some of this information in for me. So I know that Fran and Gary share their sweets in a ratio of 2 to 3. So Fran is W, so that's F. Gary is X. So Fran to Gary to Y is Olivia, and Z is J. So F to G to O to J, isn't it? Okay, and that's in the ratio W to X to Y to Z. So then Fran and Gary in the ratio of 2 to 3, so that's 2 to 3 there. And I know that Olivia and Jessica share their sweets in the ratio of 9 to 1. So that is 9 to 1. Okay. So altogether, these two here, look, is 5 parts. And these two together is 10 parts. Now we're told that Olivia and Jessica have half as many sweets as Fran and Gary. So these 10 parts actually should be as half as many as the ones that Fran have. So if they've got 10 parts altogether, then really Fran and Gary must have 20 parts, mustn't they? They must have twice as many. They should have 20 parts altogether because they've got twice as many as Olivia and Jessica. Okay, so that means we need to scale up our Fran and Gary parts by a factor of 4. Okay, So that means if I multiply the ratio of 2 to 3, I'm going to get the ratio of 8 to 12. Now that should then match with the other two, because now we're in the ratio of 10 parts to 20 parts, which is twice as many for Fran and Gary as Olivia and Jessica got. Okay, so this then should be the complete ratio: Fran, Gary, Olivia, Jessica, 8, 12, 9 and 1. So finding its simplest form, W, X, Y and Z, I think that's it, isn't it? Okay, can I simplify it down? I can't, because I've got a 1 on the end there, so I'm not going to be able to simplify it any more than it already is. Okay, so that is the final form: 8 to 12 to 9 to 1. Okay, the volume of a medal is 45 cubic centimeters. The medal is made from copper and tin, and the volume of copper to the volume of tin is in the ratio of 22 to 3. The density of the copper is 8.96 grams per cubic centimeter, and the density of the tin is 7.31 grams per cubic centimeter. Work out the mass of the medal. Ooh, okay, this is an interesting problem. Okay, so let's start at the top. We've been given the volume of the medal. It's 45, and we know it's divided up in the ratio of 22 to 3. So let's divide up that volume into the two ratios then. So my 45, I'm going to split into a ratio of 22 to 3. So basically I'm dividing a number by a ratio, aren't I? So taking my 22 parts and my 3 parts and adding it together, I'm going to get 25 parts. Dividing my 25 parts into my total volume, that is going to be 45 over 25. What's that then? 45 divided by 25 is 9/5 or 1.8. Okay, so then this one down here I'm going to multiply by 1.8, and this I'm going to multiply by 1.8. So 22 lots of 1.8. 22 times 1.8 gives me 39.6. So this one is going to have a volume of 39.6 cubic centimeters. So that's the volume of copper, isn't it? That's copper. And on this side we're looking at tin. So 3 parts tin, 1.8 per part. 3 times 1.8 gives me 5.4 cubic centimeters of tin. Okay. Now we know the density of copper. It's 8.96 grams per cubic centimeter, and we know the volume of copper, so we should be able to work out its mass. I know that density is equal to mass divided by volume, isn't it? Density equals mass divided by volume. But in this case, I know the density and I know the volume. I want the mass. So mass is going to be rearranging that, moving that up there. Look, I'm going to get mass is equal to density multiplied by volume. So here I know the density is 8.96 for copper, 8.96, and my volume is 39.6. So my copper mass, let's make this copper mass, is going to be those two multiplied together. 8.96 times by 39.6. That comes out to be 354.816. 354.816. I'm just going to write down all the digits for now. And then this side I'm going to work out the mass of the tin. So the tin mass, what's that going to be then? So I know that for the tin, I've got a density of 7.31 grams per cubic centimeters. And we worked out that we had 5.4 cubic centimeters of that. So again, multiplying those two numbers together. So my density of 7.31 grams per cubic centimeter multiplied by my 5.4 cubic centimeters of tin. what's that going to give me? 7.31 times 5.4. It's going to give me 39.474. Okay, so then the total mass then is going to be those two added together then. Total mass is 354.819 plus 39.474. So adding those together, plus 354.819. That comes out to be 394.293. Just going to round that off to three significant figures now. Going to use the first three digits then, 394 grams. Here is the first four terms of a quadratic sequence. Got -1, 3, 13 and 29. We're told that the nth term is an squared plus bn plus c. Find the values of a, b and c. Don't be scared by this bit here. This is just a general form of a quadratic, isn't it? Quadratic expression, an squared plus bn plus c, and that's what you're doing when you're finding the nth term of a quadratic sequence. It's going to be in that form, isn't it? Okay. Now, people teach this in different ways. I know a lot of teachers teach it as finding the second difference and halving that, and that's going to be your n squared term, and then doing a bit of jiggery pokery to find the b and the c part of it. I'm not a big fan of that method because I don't think it makes sense to students why it is what it is. So if you are used to doing -1, 3, 13, 29, looking at the difference, so it's going to be 4, 10, 16, and then the second difference 6, 6, and so on. So that tells you that it's going to be something to do with 3n and so on and so on. I don't like doing it that way. If you can do it that way and you're happy with it, stick with it. If you are just learning how to do it, I prefer to do it using kind of algebra and forming simultaneous equations and solving it that way. Let's have a think about the nth term. If the nth term is an squared plus bn plus c, now the first term, n is equal to 1, isn't it? So if n is 1, then if I sub 1 into this general form, an squared plus bn plus c, then you can see that 1 squared is 1. So I'm just going to get a for my first term, a times 1 squared, which is just a, plus bn, b is b, and n is 1, so that's just b, and then plus c. So I'm going to get a plus b plus c. And I know that for the nth term, for the first term, n is -1, isn't it? So that is equal to -1. So I've got an equation in a, b, and c, and it's equal to -1. Then what I'm going to do is use n is equal to 2. When n is 2, an squared, then n squared, 2 squared is 4. So I'm going to get 4a plus bn. N is 2, so that's 2b plus c. And that is equal to the second term of my expression, which is 3. Okay, so can you see I've got simultaneous equations in a, b, and c. Now I've got 3 unknowns, so I'm going to have a third equation to find 3 unknowns. So I'm going to go for n is equal to 3. Now this might look a bit weird, but it's the same for every quadratic sequence. So once you've done a few of these, you kind of recognize what I'm doing. So when n is 3, then n squared is going to be 3 squared, which is 9. That's going to give me 9a plus bn, n is 3, so that's 3b plus c, and that's going to be equal to the third term of my expression. Okay, now I don't need to use the fourth one. That's overkill for my purposes. I'm just going to use those 3. Okay, so what we're going to do, is we're going to take our 3 equations in 3 unknowns and reduce them to 2 equations and 2 unknowns, and then 1 equation and 1 unknown. How are we going to do that? Well, let's say this is equation 1, 2, and 3. Then equation 2 take away equation 1. So if I take everything in equation 1 away from equation 2, so equation 2 is, I'll just write out again. I probably wouldn't bother if I'm doing it myself, but just because I'm explaining it, I'm going to show it again. Otherwise I would just work it out. That's equation 2 and that's equation 1. So then if I subtract one from the other, then 4a take away a, that is 3a. 2b take away b, that is b. And c take away c, that is diddly zip. They cancel out, don't they? So we've got rid of c. And then 3 take away negative 1, that is equal to 4. Okay, so we've eliminated c, so now we've got an equation in a and b by taking equation 2 away from equation 1. Now, that's not good enough because I still don't know what a and b are. So I need another equation in a and b, and I'm going to get that by taking two other of my equations that I've formed and taking one away from the other. So now I'm going to take equation 3 and I'm going to subtract equation 2. That's going to give me 9a plus 3b plus c equals 13. And I've got 4a plus 2b plus c is equal to 3. And I'm going to subtract those. Okay? Now this might seem really complicated, but let's say it's exactly the same every time you solve this. So if I gave you a different quadratic sequence, you would be doing exactly the same thing with exactly the same values every time. The only thing that would change is the numbers on the end. Okay, so then 9a take away 4a, that is 5a, and 3b take away 2b is b, and c take away c, zip, and then 13 take away 3, that is 10. Okay, so now we've got two new equations. We've got equation 4 and we've got equation 5. Equation 4s and 5 are both in a and b. Okay, so we can now take those two simultaneous linear equations and solve them because we've got two equations and two unknowns now. So then what I'm going to do then is I'm going to take equation 4 away from equation 5. So equation 5 subtract equation 4. That is, what's that then? So 5a plus b equals 10. That's equation 5. And equation 4 was 3a plus b. That's equal to 4. Subtracting one from the other. 5a take away 3a. That's 2a, isn't it? b take away b. That's zip. And then 10 take away 4. That is 6. So 2a is 6, so a is equal to 3. Okay? So now I've got my value of a. I can then sub back into one of my equations, either 4 or 5, to find b. So I think I'm going to do it over here because I'm running out of space. So substitute a equals 3 into equation 4, let's say. Okay, so equation 4 was 3a plus b is equal to 4. So 3 lots of a, 3 lots of 3 plus b is equal to 4. Okay, so what does that make b then? So 3 3s are 9, 9 plus b is 4. So taking 9 away from both sides, that means b is equal to 4 take away 9, that's minus 5, isn't it? Okay, so that tells me what b is. B is minus 5. And now I know that a and b, I can substitute back into one of my original equations, 1, 2, or 3, to find my final value c. Okay, so I'm going to sub into equation 1. So substitute a is 3 and b is minus 5 into equation 1. And that should tell me what c is. Okay, so what have I got? A plus b plus c is minus 1. Well, a I said was 3, plus b, which we worked out was minus 5, plus c, which we don't know yet, that is equal to minus 1. Okay? So 3 minus 5, that's minus 2. So c minus 2 is equal to minus 1. Adding 2 to both sides, that tells me that c is equal to 1. Okay, so now I know my value of a. It was 3. Now I know my value of b, which is minus 5, and I know my value of c, which is 1. And I know the nth term is the form an squared plus bn plus c. So now it's just a matter of plugging those three numbers into that expression to find the nth term. So therefore, the nth term is a, 3, n squared, plus b, negative 5, 5n plus c plus 1. So that's my nth term. 3n squared minus 5n plus 1. Okay? Now, I find this a very logical way of doing it. Probably the first time you're looking at it, you're thinking that's a lot of algebra. But like I say, 99% of what I've done is the same for every quadratic sequence that you do. Okay? And by 99%, I mean nearly everything. So all of this, 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 all of this is going to be the same. The only thing that changes are these numbers on the end, because you get those from the actual sequence that you're looking at. So all the actual algebra is the same from one question to the next. So whilst it looks long and complicated, you know, after you've done 5 of these and it's the same every time, you go, oh, well, that's the same every time, and it gets quite straightforward to do. So I like it this way. I think it's easier than the other way, but it's for you to decide. If you prefer to do your nonsensical way of doing the common second differences and halving it, even though you have no idea why, you just carry on with that. That's no problem at all. I'll leave it to you to decide, as always. On our restaurant menu, there are 22 dishes, of which 4/11 are gluten-free, 7 rice dishes, which are all gluten-free, and 5 naan breads, of which 40% are gluten-free. This meal deal is on the menu. Choose one main dish, 1 rice dish, and 1 naan bread. How many of the possible meal deals are totally gluten-free? Okay, so let's work out how many gluten-free dishes we've got to pick from our 3 different choices. Now, if I've got 22 main dishes, of which 4/11 are gluten-free, 22 times 4/11, 22 divided by 11 is 2, times 4 is 8. So we've got 8 mains which are gluten-free. We've got 7 rice dishes which are gluten-free because they're all gluten-free. Now 40% of the naan. What's 40% of 5? 5 times 40%. 40% is 4/10, isn't it? 40 over 100, 4/10, which is 2/5. Divide 5 by 5, times it by 2 is 2. It's going to be 2 naan breads, isn't it? Okay, so that means how many different choices are there? You've got 8 choices for your main dish, you've got 7 choices for your rice dish, and you've got 2 different choices for your naan dish, which altogether is, what, 8 times 7 is 56, times 2 is 112. I make that 112 separate choices which are gluten-free. 20 people are asked which device they used more often, their laptop or their phone, and the table shows the results. For males, 2 used their laptop most and 9 their phone. For females, 4 used their laptop most and 5 their phone. I would contest that data, but anyway. 1 male and 1 female are chosen at random. Work out the probability that exactly one of them said laptop. Okay, let's first work out the probability of individual males and females saying laptop then. So the probability that a male says a laptop, that is going to be the 2 males who had laptops divided by the total number of males. Now, if you've got 2 with laptops and 9 with phones, that's 11 altogether. So the probability that a male says laptop is 2/11. Now, the probability that a female says laptop is the 4 who said laptop out of the total of 9. Okay. Now we know that, we want to work out the probability that exactly one of them said laptop. Okay, I'm going to do that in a little kind of tree, like a probability tree. So let's do the male choices first. So this is the male, and then we'll do the 2 branches for the female choices. Okay, so assuming that the male said laptop here and not laptop there, and laptop, not laptop, laptop, not laptop. Okay, so the probability that the male said laptop was 2 in 11. So the probability that the male didn't say laptop was 9/11. Okay, The probability that female said 11, probability that female said laptop was 4 over 9. So the probability they didn't say that laptop was 5 over 9. And that's going to be repeated down here because they're independent. Okay, so then we're interested in exactly one of them said laptop. So the probability of exactly one, that is going to be either that the male said laptop and the female didn't, or it's going to be that the female, the male didn't say laptop, but the female did. Okay, so it's those two branches, isn't it? So it's going to be the branch laptop, not laptop, or, which is plus in the land of probability. I'm just going to move this over because I'm kind of busting out the edge of the screen here. So let's just move this over to the side a little bit because I ran out of space. Tum-tum-tum-tum-tum. Let's just move it that way a little bit. Yeah, that fits better. Okay, so the probability of exactly one was probability of laptop for the boy, not laptop for the girl, plus the probability of not laptop, laptop then. Okay, so probability of laptop, not laptop, that's the yellow root. Okay, and that is going to be 2/11 times 5/9. And then probability of not laptop, laptop. So boy not laptop, girl laptop. That was going to be the green root. So that is 9 over 11 times 4 over 9. Okay, so what's that then? Calculator, what is 2/11 times 5/9 plus 9/11 times 4/9? That comes out to be 46/99. Part B says two males are chosen at random. Work out the probability that they both said phone. Now this is going to start out the same way, isn't it? With males either choosing laptop or not choosing laptop. In other words, choosing phone. Okay, and the probabilities are going to start out the same. We've got 2 out of 11, don't we, who chose laptop, and 9 out of 11 who didn't. But then on the second selection, remember that you've already picked one of the guys, haven't you, to ask. So then if you're going to pick again, you're going to have different probability outcomes depending on what happened first time round. So let's assume you picked one of the guys who preferred working on their laptop. When you ask the next set, you've got one less to pick from of people altogether, and one less person who chose laptop because you've already picked one earlier. And the same earlier for the second fraction, you're going to have out of 10 there, and you've still got all 9 to pick from there. Okay, so then in the second route, if I pick not laptop first time round, I've still got the 2 guys who preferred laptops to pick from, but then that is out of 10, and I've got one less people who didn't like laptop out of 10 in that direction. So that's laptop, not laptop, laptop, not laptop. So then the probability of both phone, just one route through, isn't it, this time? That means not laptop, not laptop. So it's going to be the 9/11 times 8/10, which is what? 9/8 is 72, 11/10s are 110, sorry. So that's 72 over 110. Question 17. A, B, and C are points on the circle. Center O. BD is a tangent to the circle. OCD is a straight line. Work out the size of angle X. Okay. Now, in order to work this out, I'm going to have to apply various circle theorems to this diagram. Now, first up, I've been told that BD is a tangent to the circle. So that means that this line here, OB, which is a radius drawn at the point of contact, that needs to be at right angles to the tangent, because that is always a thing. So those two lines must always be at a right angle. Okay. Now the second circle theorem that I can use is the fact that the angle at the center is twice the angle at the circumference, like that. So that angle there being 32, if I double it up, then I'm going to get the angle here, which must be 64. Okay, so that angle must be 64. So then I found two angles in this triangle down here then, haven't I? Okay, and I know that the angles in the triangle add up to 180 degrees, and I know the other two, so I should be able to find x. So I should know that x plus my 64 plus the 90, my three angles in the triangle, add up to 180 degrees. So if I add those two together, so that's x plus 154 is equal to 180. So taking 154 away from both sides, then x is going to be 26, then, isn't it? So that's my answer, x is 26. Solve the inequality x squared minus 5x minus 6 is less than or equal to 0. Okay, so I think first off we need to factorize this, don't we? So let's say that's the same thing as two brackets multiplied together. So I've got x at the start, x squared, so I'm going to have x and x here. Now let's have a quick look at the constant on the end, negative 6. What are the factor pairs of 6? 6 has factor pairs 1 and 6, 2 and 3. So they've got to be one of my numbers, and we're looking for a factor pair that adds up to negative 5. Okay, so but remember, one has to be positive and one has to be negative. Like 2 and 3 adds up to 5, but we're actually going to be having one positive and negative one. So I actually think the one we're looking for is this pair here, the 1 and the 6, isn't it? So it's going to be plus 1 because and minus 6. That's going to give me negative 5 in the middle, isn't it? Okay. Now if this was an equation, it would have roots then at negative 1 and positive 6 then. So if I was going to draw a sketch of this quadratic, all quadratics have this kind of parabola shape, don't they? Okay, and then this particular parabola is going to have two roots, which we've just kind of worked out, haven't we? So the one on the left, x plus 1, that's going to give you a root of minus 1, and x minus 6 is going to give you a root of 6. So this graph is going to look something like this. So where would the y-axis be? Doesn't really matter. Be somewhere in between. Now we want to know when this function is less than 0. So what sections of the number line for x is this graph negative? Okay. Well, it's below the axis in this section from here to here, isn't it? Okay. On the other sides, here it's above the axis, and here it's above the axis. So it's just those bits between minus 6 and 6 where this function is below the x-axis or negative. Okay, so the region we're looking for is the region between minus 1 and 6. So x then lies between 6 and minus 1. Now I do recommend that you do a sketch like this, because otherwise it gets a bit confusing, and I know many students make mistakes with it. So I do recommend drawing the parabola, working out where the roots are, and then thinking where is that graph greater than or less than 0. I think that's the smartest way of doing it. Okay, so that's my range. X lies between minus 1 and 6. Show that for x not equal to 0, x plus 4 divided by 3x minus 5 over 2x can be written in the form ax plus b over cx, where a, b, c are integers. Now don't worry too much about this bit. They have to put that in there, otherwise you're going to get division by 0, aren't you? Because I've got x plus 4 divided by 3 lots of 0, which if you've ever typed in division by 0 into your calculator, know is undefined. So that is all just really excluding that as a possible solution, just so that you're not dividing through by 0. Right, so what we want to do is we want to take these two fractions and put them over a common denominator then, don't we? Now normally with fraction subtraction, that's what you do. You would take your two denominators, you would find a common denominator, and then scale up your numerators accordingly. And we're going to do the same thing here. So I've got x plus 4 over 3x minus 5 over 2x. And we need to find a common denominator. So I've got 3x and 2x. So what's common? Well, they both got x in it, so I can have x as part of my common denominator. And I've got the numbers 3 and 2, and so the lowest common multiple of 3 and 2 is going to be 6. So I'm going to use 6x then as a common denominator. So 3x goes into 6x twice, so I'm going to multiply up this one by a factor of 2 then, aren't I? So I'm going to get 2 lots of x plus 4, subtract, and my 2x goes into 6x 3 times, so I'm going to multiply this one up by a factor of 3. So that's going to be 3 lots of 5. Multiplying out the brackets on the top, 2x plus 2 lots of x plus 4 is 2x plus 8. Don't forget to multiply the 4 by 2, minus 15 all over 6x. So that's going to be 2x. 8 take away 15 is minus 7, isn't it? So there we go, 2x minus 7 over 6x. So that is of the form ax plus b is over cx, where a is 2, b is minus 7, and c is 6. So that is all fine. In triangle JKL, M is the midpoint of JK. Jn to NL is in the ratio of 3 to 2. And we're told that the vector KL is 7a and the vector n to L is 4b. Okay, work out the vector j to m in terms of a, b, give your answer in its simplest form. So what we need to do is we need to find this vector here then, isn't it? Okay, we need to find that one. What do we know? We only know this direction here and we know this direction here. So basically what we're going to have to do is to find j to k and then halve it to find j to m. Okay, I think that's what we're going to have to do. Now we've got some information up here that isn't in the diagram. First off, we've got that m is the midpoint of jk. So that means that this distance is the same as this one then, isn't it? Okay, so let's just mark that on. And we're also told that Jn to NL is in a ratio of 3 to 2. So Jn to NL, so this is 3 to 2 along here. Okay, so if this is in the ratio of 3 to 2 and NL is 4b, then if I divide that by 2 and times it by 3, it should tell me that j to n then, this part down here, is going to be 4b divided by 2 times by 3. It's going to be 6b, isn't it? That's going to be 6b. I'm just going to write that down, that if I've got, if n to L is 4b, and I know that j to n is 3 halves of 4b, then I know that j to n is 6b. And that tells me also that j to L is going to be j to n plus n to L, which is going to be 6b plus 4b, which is 10b. Okay, so I know j to L is 10b. I already know k to L is 7a. So then I can find an expression for j to k. So this distance all the way along here. Well, going the other way actually. So what is the vector jk then? Going along places that I know. I can't go direct because I don't know anything about that line yet, but I know the other route. So I know that I can get from j to k by going from j to L and then going from L to k. Okay, and I know that j to L is 10b because I just found it, and I know that L to k is going to be minus 7a. Okay, because I'm going against that arrow, aren't I? So it's negative Okay, so j to k is 10b minus 7a. Now what we want to know is what jm is. And we know that jm is the midpoint of jk. So j to m is going to be half of the vector j to k then, isn't it? Okay, so that is going to be half of 10b minus 7a, which is going to be, just multiplying that out, I'm going to get 5b minus 7 over 2a, like, just going to write it like that, 7 over 2a, it's like 3.5a. So the vector I want, j to m, is 5b minus 7 over 2a. The cross section of an earring is a semicircle centered C, radius 25 millimeters. The earring is black and white, the shaded area is black. Okay, so that bit in the middle is not a hole, it's a white bit. So the sector BCD is white and has a radius of 12 millimeters. There's the sector. So that's all the information on that page. Is more than 20% of the semicircle white? You must show your working. Okay, so therefore we're going to have to work out the two different areas and then see if one is 20% of the other. Okay, so where should we start? Should we start with the, well, let's start with the sector, because we have to take the sector away from the other bit, don't we? So let's start with the sector. Sector has a radius of 12 and an angle at the center of 150. So the area of the sector then of the sector is equal to 150 360ths of the area of a circle, which is pi r squared, where r is the radius, which is 12. So it's that, isn't it? So the area of the sector then is going to be 150 divided by 360 times 12. I'm going to leave it in terms of pi for now because they both have pi in it. And I want to compare them, and the pi's will drop out. So that is 60 pi. I'll keep the numbers easier if I do it this way. So the area of the white part then is going to be 60 pi. So what about the semicircle then? The area of the semicircle is going to be 1/2 of pi r squared then, isn't it? So what is the radius of that? 25. So it's going to be 1/2 of pi times 25 squared. So 25 squared, 625 divided by 2, 312.5. I'm just going to leave it as 625 pi over 2 for now. Okay, so the percentage that's white then is going to be 60 pi divided by 625 pi over 2. So dividing through by a fraction is the same as flipping that fraction over and multiplying. So that's going to be the same as 60 pi times 2 over 625 pi. So that's where the pi's are going to cancel out. So then I've got 60 times 2 divided by 625. 60 times 2 divided by 625 equals 0.192. So as a percentage, that's 19.2%. So the question was, is it more than 20%, or is more than 20% of the semicircle white? And we found it's 19.2, so the answer is no. It's less than 20%. Work out the coordinates of C when ABCD is rotated 90 degrees clockwise about O. then translated by minus 6, 2. Okay. If you're not so good with rotation, it's probably best to do this with tracing paper. Just lay your tracing paper over the shape, then trace your shape out, and then hold down your pen at the origin and turn it 90 degrees clockwise. Sometimes helps to do a little cross in the center so you can keep track of how far you're meant to turn. If you do that, you should find that B ends up here. C is going to end up down here. A is going to end up here, and D is going to end up down here. Okay. If you get good at it, you can do it without tracing paper, but you have to be pretty pro, I think, in order to do it. Then join them up with a straight line. Okay, so that's going to be my shape after the rotation. So that is C dash, B dash, A dash, D dash. Okay, and then I'm going to translate it by minus 6, 2. Now, minus 6, 2. The top digit is in the direction of X and the bottom digit is in the direction of Y. So I need to go negative 6 digits in the direction of X. That means I'm going to go 6 units to the left and 2 units in the direction of Y, which is 2 units up. Okay, so taking the point B to start with, I'm going to be going 1, 2, 3, 4, 5, 6 to the left, 1, 2 up. I'm going to end up at that point there, aren't I? Okay. Let's get rid of that. So that's going to be my B dash. So it's not, it's going to be B double dash. B double dash. Do the same thing with C. So if I start at C and I go 1, 2, 3, 4, 5, 6 to the left and 1, 2 up, takes me to that point there. That's going to be C double dash. Okay. And then A. 2, 4, 6 along, 2 up, takes me to here. Okay, that's going to be A double dash, and then finally D. 2, 4, 6 along, 2 up, takes me to there. Okay, so that then is D double dash. Okay, and again I'm going to join them up into a shape now. Now found all the corners. Okay, and that is my new shape. So remember, we needed to work out the coordinates of C. So now C is over here, isn't it? What coordinates is that then? So then the coordinates of C double dash is going to be minus 5, comma, minus 2, and is it negative 5, negative 2. A equals 4.72 to 3 significant figures. B equals 1.58 to 3 significant figures. Work out the upper bound of A over B. You must show your working. Okay. Now when I'm doing these limits of accuracy questions, I like to draw a number line and mark on the number they give me. So that is 4.72. Now, that's been rounded to 3 significant figures. Now the third significant figure is that 2 there, which is in the hundredths column. So 1/100th more than 4.72 would be 4.73. So one number up on my number line is going to be 4.73. 1/100th down would be 4.71. So then the numbers that are going to round to 4.72 are going to be like halfway between those or closer, aren't they then? So this range of numbers here. Okay. So the lower bound for A is going to be 4.715 because that's halfway between 4.71 and 4.72. And the upper bound is going to be 4.725 because that's halfway between 4.72 and 4.73. Okay, now that's A. I'm going to do the same thing for B. B is 158 to 3 significant figures. So I'm going to draw another number line. I'm going to mark on the number they gave us, which is 158. Now this time the third significant figure is that 8 there, isn't it? 1, 2, 3, it's the 8. So that means this number's been rounded to the nearest unit or whole number. So one whole number up from 158 is going to be 159.
one whole number down from 158 is going to be 157. So that means that the numbers that round to 158 are going to be halfway between those or closer. So this range, all these are going to round to 158. That lower bound there is halfway between 157 and 158. That's going to be 157.5. And the upper bound is going to be halfway between 158 and 159. That's going to be 158.5. Okay? Right. Now we need to work out the upper bound of A over B. Okay? So we've got two possible values of A that we're going to use. We're going to use the upper bound and the lower bound. And then we've got two possible values of B. And we want to pick the values of A and B that are going to deliver us the largest value of A divided by A divided by B. So A divided by B, what's that then? Now to get that as big as possible, I'm going to pick the biggest value of A that I can, which is that one, isn't it? Okay, I'm going to pick my biggest A, which is 4.725. And I'm going to divide it by, now, do I want the biggest or the smallest value of B? If I pick the biggest one, I'm going to divide A by a bigger number and I'm going to get a smaller result than if I divide it by the smaller one. I'm going to get the bigger result, aren't I? So I'm actually going to use the lower bound of B, because that is going to deliver the largest value overall for A over B. Now if you can't figure these out, the alternative is just to try all the various combinations. There should be 4 combinations altogether. Try upper with upper, lower with lower, upper with lower, lower with upper. You just work all 4 of them out and then you see which one delivers you the bigger one. I'm pretty good at reasoning it out, so then I'd rather spend the time reasoning and do the calculation once. But if you're not able to reason it out that way, then like I say, the alternative is just to work out like a brute force attack. Just work all 4 out and then you see which one is going to give you the biggest number. Right, I'm pretty confident this will though. So 4.725 divided by 1.57.5, that comes out to be 0.03. Okay, so that is my upper bound. So that is my upper bound of A over B. It's 0.03. Okay. A shape is made up by joining a triangle ABC to a semicircle with diameter AC. Work out the total area of the shape. So what we're going to have to do, we're going to have to find the area of the semicircle and the area of the triangle and add them together. So the semicircle area is going to be fairly straightforward, you'd think, wouldn't it? Because the area of a circle is pi r squared over 2. So we need to work out what pi r squared over 2 is, but that means we need to know what r is, and we've not been given r. So we're going to have to work out what r is. So r is going to be half of this diameter here. So we're going to have to find the line AC. Okay. Now the other area, the area of the triangle, is going to be fairly straightforward because it's a non-right angle triangle where we know 2 sides and the included angle. So that one, that one's fairly straightforward actually. We can just use the trigonometric formula for area of a triangle, which is area equals a half AB sine C. Okay, we know everything in there, so we can work that one out, no problem at all. That's going to be a half times A, which is 8, times 10, which is 10, and times the sine of 114. So that's just tap it into the calculator and find out what the answer is. That's the easy squeezy bit. So half times 8 times 10 times the sine of 114. Okay, that comes out to be 36.5. I'm going to write an extra digit down because I'm going to round it off later. So I'm going to write down 4 digits and I'll drop down to 3 later. Okay. So that's that bit done. Now the next thing we need to do is know what AC is. So we want to find the third side of a non-right angle triangle, given the fact we know the other 2 sides in an angle. This is clearly a job for our trigonometry and non-right angle triangle rules, but is it the sine rule or is it the cosine rule?
The sine rule tells us about opposite pairs, and the cosine rule tells us about three sides. Okay, so this one is about three sides because we've got two sides, we want a third side. So it's going to be the cosine rule. So using cosine rule, which states that we want B, don't we? This is side B. We label up the sides opposite the angles. So this is going to be side A, and this is going to be side C. So we want B, and so the cosine rule says B squared equals to the other two things squared, A squared plus C squared, minus two lots of the other two things multiplied together, multiplied by the cosine of your angle. Okay, so that's what we're going to do. B squared equals A squared plus C squared minus 2AC cos B. Now, sub in. A is 10 squared. C is 8 squared minus 2 lots of 10 lots of 8 times the cosine of 114. Okay, and I tried to do as much of this by hand first because I think you're more likely going to make a key in area on your calculator with the complex thing than you are by squaring 10. You should all know that 10 squared is 100 and 8 squared is 64, and you should be able to multiply 2 times 10 times 8 in your head. That's 160. So just do the maths that you can in your head that's easy to do, because it doesn't take very long, and like I say, you are more likely to make a key in area in a horrendous long calculation you have to type in your calculator than you are doing some basic maths, which, given that you're a top set, you're a higher tier student, you should be able to cope with. Right, so 164 minus 160 cos 115 then. So I've made it super easy for me to type that in because I've done all the maths along the way and reduced it down as much as possible. That comes out to be 229 and change. Okay, but don't forget you need to square root that. It's the square root of 229 and change. I'm just going to write that down, but I'm going to square root my whole value. So square root answer 15.14. I'm going to write it down to 4 significant figures first because we haven't quite finished. And then I'm going to say then, so that's my length B, and then, so now I know what AC is, which is the diameter, so then my radius is going to be half that then, isn't it? It's going to be divided by 2, so that's 7.568, 7.568, okay, and now we can find the area of the semicircle then, can't we? So then the area of the semicircle is going to be pi lots of 7.6, so 568 squared over 2, which is equal to, so that thing squared divided by 2 and times by pi. I make that 89.96. So then I've got the area of the semicircle, got the area of the triangle, so then the total area is going to be those things added together. I feel like I'm on a roll. 89.96 plus 36.54. What's that then? Plus 36.54. Now I'm going to round it off to 3 significant figures. I was keeping it to 4 significant figures as I was going through, so that when I could drop down to 3, I'm not going to lose too much accuracy along the way. So 126 units squared centimeters. Sphere has radius r centimeters. An approximate value of r can be found using the iterative formula rn plus 1 equals the root of 239 divided by rn. The starting value is r1 is equal to 7. Work out the values of r2 and r3. Okay, so what I like to do with these is I like to type in the first value into the calculator and then press equal, so it's the last stored value. Okay, and then I'm going to get the next value by taking the square root of 239 divided by Rn, which I'm going to use the answer key. So basically the last calculated value is going to come back and go into there. Okay, so R1 we know is 7, then R2 is going to be the root of 239 over 7, and I'm just going to press my answer key and find out what that is. That's equal to 5.843. I'm just going to write it down to 4 significant figures for now. 5.843, and then R3 we're going to get. All I need to do now is I'm going to write it out. So that's going to be 289 over 5.843. But because we get the way we set it up on the calculator, all I have to do is press the equal button again, and it's going to feed in R2 into the formula, and it's going to give me R3 straight away. So that's 6.395. And again, we're just going to write down the first 4 significant figures for now. So that's 6.395. Okay, so we're done with that. Part B says continue the iteration to work out the radius to 1 decimal place. So basically we're just going to have to keep on finding more and more values until it settles down on the first decimal place and we start getting the same answer over and over again. So we've already got R3, so let's go on to find R4. Now again, I'm just going to press the equal button. That's going to feed in my R3 value and give me the R4 value. And again, I'm just going to write down the first 4 significant figures, 6.113, and I'm going to keep going until it settles down. So then the next one, R5, is equal to 6.253, and then R6 is equals 6.183. Still jumping around a little bit, and wait until it settles down. R7 equals 6.218. Still bibbling between 1 and 2. Next one, R8 equals 6.200. R9 equals 6.209. And R10 is equal to 6.2. It seems to have settled now, doesn't it? 204. So the last digit is still kind of resolving itself. And then I've got R11 is 6.207. And then the next one. And if I keep pressing it now, I think I'm just going to keep pressing it now. Can you see it just kind of resolves to 6, goes down to 6.2058. Just going to round off to 6.206. That's where it kind of settles to. Okay, so then you can see that to 1 significant figure actually settled pretty quickly. It settled on the 6 from the first, well, from the second, from R3, didn't it? And then it started being 6. But it didn't really settle on the second decimal place until we got to R7, R8, and then it stayed being 2. Okay, and then you can see then we started getting the third decimal, the third significant figure there, and it took a little bit longer for the 4th digit to settle down. But we just want to know what the radius is to 1 decimal place, so that is equal to, so the radius is equal to 6.2 to 1 dp.
Mr. T, he's the best, helps you ace every